Biot Savart's law. Consider a current element DL of conductor XY. Here, this is a conducting wire. We are considering this portion as current element DL, and this conductor carries current I. We have to find out magnetic field at point P, whose position is represented by vector R. Let magnetic field at this point is dB due to this current element, and it will be perpendicular downward. According to Biot Savart's law, the magnetic field dB is directly proportional to current. dB is also directly proportional to length of current element. dB is inversely proportional to square of distance, and dB is directly proportional to sine theta. Here angle is shown that vector R makes with the current element. Now, if we combine, we get dB proportional to I dl sine theta divided by R square. Here we need a constant, so we write dB equal to mu naught upon 4 pi I dl sine theta divided by R square, where mu naught upon 4 pi is a constant whose value is 10 power minus 7 Tesla meter ampere minus 1. Now, if we want to write the same relation in vector form, then we can write it as vector dB equal to mu naught upon 4 pi then I dl cross vector R divided by R cube. Here, vector R cap is equal to vector R divided by modulus R, and that has made this R square to R cube. Like it was dB equal to mu naught I dl sine theta divided by R square times R cap if it is vector. And R cap can be written as vector R divided by modulus R. Hence, this R square will become R cube. So that is shown here. So this is dB equal to mu naught upon 4 pi I dl cross R divided by R cube. And direction of magnetic field can be found by using the law of cross product, like I j k. If dl is along I cap and suppose R is along j cap, then I cross j will give k cap, which will be direction of magnetic field. Now, the relation between mu naught, epsilon naught, and C. We know that mu naught upon 4 pi equal to 10 to the power minus 7, or 4 pi upon mu naught equal to 10 power 7. Also, 1 upon 4 pi epsilon naught equal to 9 into 10 to the power 9. If we multiply 1 and 2, so 4 pi upon mu naught times 1 upon 4 pi epsilon naught will be equal to 9 into 10 power 9 into 10 power 7. That is 9 into 10 to the power 16, which is 3 into 10 to the power 8 whole square. And if you remember, speed of light c equal to 3 into 10 power 8 meter per second. So here it is equal to c square. And here 4 pi will cancel out. So we will be left with 1 upon mu naught epsilon naught equal to c square, or c equal to 1 upon root of mu naught epsilon naught. And suppose you want to find out the dimension of 1 upon mu naught epsilon naught, then it will be dimension of speed squared. That is dimension of 1 upon mu naught epsilon naught equal to speed, dimension of speed, length upon time, whole square. I think you must have understood. Now, let's see question number 1. A wire placed along the north-south direction. Suppose we denote this is north, this is south, this is east, and this is west. So wire is placed along north-south direction, and it carries a current of 8 ampere. So it has current 8 ampere. So we consider its small portion here and find the magnetic field due to 1 cm piece of wire. So we consider here small portion 1 cm, and the point is here, that will be angle 45 degree, because here it says to the magnetic field due to 1 cm piece of wire at point 200 cm northeast. Northeast means point is making 45 degree, and length is 1 cm. This length r will be 200 cm. So we write the parameters. So here I equal to 8 ampere, dl equal to 1 cm, that is 10 to the power minus 2 meter, and r equal to 200 cm, which is equal to 2 meter, and theta equal to 45 degree. So if we apply the formula, dB equal to mu naught upon 4 pi I dl sine theta divided by r square, and we put the values. So 4 pi, so we can put direct value mu naught upon 4 pi equal to 10 power minus 7 multiplied by I is 8 ampere into dl is 10 power minus 2 into sine 45 degree, 1 upon root 2 whole divided by r square. R is 2 square. It will be equal to 1.4 into 10 to the power minus 9 Tesla. And the direction of magnetic field will be perpendicular downward. Now, some questions for you. Question number 2. An element delta L equal to delta X I cap is placed at the origin and carries a current of 10 ampere. What is the magnetic field on y-axis at a distance of 0.5 meter? We are given delta X equal to 1 centimeter. Its answer is 4 into 10 power minus 8 Tesla. So here theta is 90 degree, because situation will look like this. This will be current element and point is here. So this theta is 90 degree. Other values are given, and you can use mu naught upon 4 pi as 10 power minus 7. So you will get an answer for this. Now, let's see question number 3. An element delta L equal to delta X I cap is placed at the origin as shown. Here, this is current element, and it is along x-axis, and point is on y-axis, and other informations are there. Like current is 2 ampere. What is the magnetic field at a point P on the y-axis at a distance of 1 meter? This distance OP is given as 1 meter due to the current element dx. Dx is 1 centimeter. So this current element dl is equal to dx, that is 1 centimeter. Also give the direction of the field. So answer to this question will be 2 into 10 power minus 9 Tesla, and the direction of magnetic field will be along positive z direction. You have to solve these questions. Thank you for watching.